Welcome to Precalculus Concept 25B underneath the right triangle trig. We're going to spend some time talking about the function values for pi over 6, pi over 3, and pi over 4. We should be really familiar with pi over 4 as a class. That's nothing more than 45 degrees. Today we're going to get into pi over 3 and pi over 6. These are the three most important angles that we could learn in precalculus. There's only two boxes, so let's get going here. So box number 1, let's talk about the 30, 60, 90 degree triangle. And I want you to now notice that 30 degrees is the same thing as pi over 6. 60 degrees is the same thing as pi over 3. 90 degrees is the same thing as pi over 2. Just to keep radians in the forefront of our mind. Okay, let's back up just a moment and think about geometry class. So in geometry class, you studied two special right triangles, a 45, 45, 90, and a 30, 60, 90. We already spoke about the 45, 45, 90, so let's concentrate on the 30, 60, 90 here. So here's my 30 degree angle, here's my 60 degree angle, and of course the right angle is my 90 degrees. Now, it doesn't matter the size of the triangle. What only matters is the relationship between the sides of the triangle. So you may recall that if you were given any length of x on the side that is opposite the 30 degree angle, then the side that is opposite the 60 degree angle will be x multiplied by a radical 3. And then, of course, the hypotenuse will be 2x. This should not be anything new to any of us in precalculus. So let's ask ourselves how we could transfer from geometry over into the unit circle. Remember, the unit circle is a circle with a radius of 1, so the hypotenuse in this case would be a radius of 1. So if it is 2x now, if I divide this by 2x, then I would get a value of 1 here. So that means I have to divide everything else by 2x as well. So I would get 1/2 on this side, so now this side becomes 1/2. And the x's cancel here, and I end up with a radical 3 over 2. So this is where all these values come from. They come from geometry. They're not made up, and they're not anything crazy. They just simply look at, okay, if we already know something about the triangles and the sides of a triangle geometry, and we want to apply it to a unit circle, we can do that. Now, what's the benefit of doing that? Here is the benefit of doing such as this, okay? If I'm now concentrating on the 30 degree angle, if I want the exact values for 30 degrees, I can now define them, right? The sine of 30 degrees has to be, remember, it is the opposite to the hypotenuse, so it's just going to be 1/2. So now I have an exact value for the sine of 30 degrees. Let me make this a little smaller so we can see all at once, okay? Now, if I want to talk about the cosine of 30 degrees, remember, the cosine is the adjacent to the hypotenuse, so it is an exact value of radical 3 over 2. That should be a 2, sorry. And if I want the tangent of a 30 degree angle, right, the tangent is the opposite to the adjacent, so it's 1/2 divided by radical 3 over 2, which of course gives me 1 over rad 3, which I can then simplify to rad 3 over 3. So now I know the sine of 30 degrees is 1/2, the cosine of 30 degrees is rad 3 over 2, and the tangent of 30 degrees is rad 3 over 3. It should also be noted that I could interchange 30 degrees with pi over 6. So if I ask you for the exact value of the sine of pi over 6, it's the same question as sine of 30 degrees. It'd be 1/2, and all the way down as well. Okay, now let's take a look at the 60 degree angle. If I look at this angle up here, I could ask you for the sine of 60 degrees. Well, again, it's the opposite sides of the hypotenuse, so it is just rad 3 over 2. I could ask you for the cosine of 60 degrees, and it is the adjacent to the hypotenuse, so it is just 1/2. And of course, I could ask you for the tangent of 60 degrees, and it would just be rad 3 over 2 divided by 1/2, which would just give me radical 3. Similarly, if I could exchange 60 degrees for pi over 3 and ask you for the exact value of the sine of pi over 3, and you could then refer to that picture and tell me it is rad 3 over 2, and we could use this all the way down in radians as well. So there it is. This picture is really, really important, and I want to take some time to develop it with you and tell you where it comes from, and hopefully it's not really a big mystery anymore, but the takeaway is that we can now talk about exact values for 30, 45, and 60 degrees. Okay, box 2 is an example and a you try kind of simultaneously. So the first thing I want you to do is if I give you that this side is a value of 1, I want you to copy the picture and fill in the other two sides of the triangle, given that it is a 30, 60, 90 triangle. Okay, hopefully you filled it in correctly, and you have that the side that is opposite the 60-degree angle is rad 3/2, and the side that is opposite the 30-degree angle is 1/2. Now, I would like you to fill in this entire box right here. I'll give you one of them, okay? The sine of 30 degrees, or the sine of pi/6, is going to be 1/2. So it's going to be your job to fill in all rest of those circles, or excuse me, boxes. Okay, here's the correct answer. Hopefully you got all of the same values that I did, so take a moment and check and see. And if you are correct, then you are in the right spot and you are on a good path.